Okay, so we are reviewing for our Unit 2 test. Welcome. This is PreCalc Unit 5 review. I'm going to start doing some problems until I see others asking questions either in the chat on the YouTube page or via tweets. So, and I'm here for about 35 or 40 minutes until they kick me out of my classroom. So I'm going to start with some problems from the Chapter 5 review packet that you got, not the practice test, but the other packet. And let me know if you have questions. All right, so this is number 1. You're asked to simplify each expression. Don't forget to, if you're choosing a note card, to get your note cards made tonight. You will not have time in class tomorrow to make them. We're going to turn in bookwork and then immediately start with the test. Another change about the test from class today, I'm going to give you guys the calculator active part first because I think that'll take less time for you to do. And it'll probably be easier for the most of you so that you can have the calculator inactive part and kind of spend more time on that afterwards, not having to worry about managing your time for the calculator active part. All right, so number 1, sine squared of beta, cotangent of beta over cosine of beta. We want to simplify. The first thing I see is there's a sine and a cosine, and then there's this not sine or cosine. So I'm going to use my quotient property and change this cotangent to cosine over sine. Whoop. Okay, so then we have sine squared of beta. This is the same thing as sine squared of beta over 1. So this sine of beta, if we're just looking at from the numerator, this sine of beta is going to cancel with one of those sine of betas. There's 2 factors of those there. So now we're left with sine of beta, cosine of beta. Okay, no more fraction inside the numerator. And cosine of beta in the denominator. Now we can, we've got a factor of cosine of beta on the top and the bottom. So we're left with sine of beta as our simplified version of number 1. Let's see if there's anybody here. I don't know how this works. I've never done this before. Let me know if you have questions, people. Okay, I'm going to keep doing problems. All right, number 2. All right, we have sine of x, take away sine of x, cosine squared of x. Same directions, we want to simplify. We've already got sines and cosines. I see a sine in both of these terms. So I'm going to go ahead and factor out a sine. Okay, don't forget to put that 1 there as a placeholder for that first sine. And we have cosine squared left. Ooh, that's our one of our Pythagorean identities. If we solve for sine squared of x, let's replace all of this with sine squared of x. So we get sine of x times sine squared of x. Okay, so we have 1 factor of sine, 2 factors of sine. That leaves us with 3 factors of sine. So we should be left with sine cubed of x. Ooh, can you please do number 8 from the law of cosines CUDA worksheet? Yes, I know you asked that in class and I didn't do it. So yeah, let's do that right now. Law. All right, let's see if I can find that. All right, number 8. Okay, we're asked to find the measure of angle B. In triangle ABC. So let's see, we've got angle A, we have sides little b and little c. So we have side, angle side. So that's definitely going to be law of cosines. And let's see, we're looking for a missing angle. All right, so if we're looking for that missing angle, we want to set it up so that the side opposite that angle is always the one by itself on the left side of the equation. Okay, so little b is opposite big B, so I'm going to say 17 squared by itself. And then always start off with like a Pythagorean theorem, kind of a vibe, equals 22 squared, and I don't have my third side, I don't have little a. So we can't have two unknowns in our equation. We can't have little a unknown and angle B unknown. So we're going to have to find little a first before we can find angle B. Okay, so we're going to do this in 2 steps. We're going to save this for later. Okay, we'll come back to that. And we're going to have to find little a. So again, we're looking for little a. So that's going to be by itself on the left side. We know the other 2 sides, and we know our angle opposite little a. So we're going to be able to fill in this whole right side of this equation. So we've got other 2 sides squared and summed. Take away twice the product of those 2 sides times the cosine of that angle. All right, let's see. We've got no variables on the right. We've got just our variable on the left. So let's square root both sides. We don't have to worry about plus minus since we're looking for the length of a side. So it's got to be positive. So a equals square root of all that. I'll plug that in my calculator. All right, so square root 22 squared plus 17 squared, take away 2 times 22 times 17 times cosine of 143. I'm going to make sure I'm in degree mode. I'm not. Okay, so it should look something like that. All right, and then let's see what we get. So it's looking like 37.019. 37.019. Oh, yeah. And let's see if that's what we're supposed to get. I have no idea. So let's keep going. Let's see if we can find the measure of angle B. So now that we found our third side, now we can come back to our equation down here and we can fill in that A. Ooh, I'm going to go in and I'm going to store that side into A so that I don't have to do any rounding. Okay, so we come down and we press the stow button. And I'm going to put it in A. So alpha A. Okay, so that's going to store it. So now I'm going to put a little star beside this to remind me that I stowed it in A. And then now when I plug it into my law of cosines formula, I'm just going to put A squared, just like that. Okay, save myself some time and to remind myself that I know it's in my calculator. Okay, so minus 2 times 22 times A cosine of the angle opposite 17. That's our unknown. Okay, remember, we know what A is. So that's not our unknown. This capital B is. So we want to get this B by itself. Okay, I'm immediately going to subtract these two terms from both sides. Remember, we've got three terms. All of this is one term, so don't try to combine all these numbers together. Okay, so I'm going to do 17 squared minus 22 squared minus A squared. That's going to be equal to, let's see, negative, that's going to be 44A cosine of B. All right, I want to get that cosine of B by itself, so I'm going to divide both sides by that coefficient, negative 44A. Okay, that's going to give us cosine of B is 17 squared minus 22 squared minus A squared, all over negative 44A. Okay, so then angle B equals inverse cosine of 17 squared minus 22 squared minus A squared over negative 44A. All right, and I'm going to plug that into my calculator. So inverse cosine, I like to use the fraction function. And again, you can simplify as much as you would like to along the way. I'm okay with having these squares in my formula until the very end. If you're not, go ahead and square them, see what they are. Okay, and remember, you just call on A, alpha A. Don't plug in that rounded value. Okay, don't square until, or don't round until the very end. And negative 44A in the denominator. Okay, so we should get something that looks like this if you use the fraction function. And let's see what we get. So we get 16, is that 0.0437, 16.0437. 16.043.7, and if you follow the directions on the sheet, it says round the nearest tenth, so that'd be 16.0 degrees. Okay, and if you wanted to solve the whole triangle, subtract our new angle B and 143 from 180, and that'll give you angle C. All right, I have no idea if people can hear me or see me, or if anybody's watching, so let me check on some things. Okay, looks like some folks are watching. Questions, more questions. I don't know how this chat thing works. If you can see something, I'm going to say something. Yo! Chat. Questions. What do we got? So we have any more tweets. Boom. Done. The heart just became a check. It was a star 2 days ago. Then it was a heart. Now it's a check. All right, what do we got? What's next? "27 from bookwork, page 460. We'll see if we can find that. 27 bookwork, page 460. Oh no. Oh no. Gotcha. I don't know what to do with that. I don't know how this works. See if I can enable. Oh, live chat. It says enable from here. I don't know how to fix that. Sorry. How about options? I don't know. Yeah, just keep tweeting at me. Oh, never mind. All right, let's see. Where did our page 460 go? Katie said number 27. Is that right? 27. All right. Okay, directions say prove the identity. Okay, so prove the identity. Let's see what we got. We've got tangent squared of x over secant of x plus 1 equals 1 minus cosine of x over cosine of x. Okay, so we typically start with the most complicated side, which looks like the left. And we want to get to cosine. So don't forget, always keep the other side in mind as you're working on a proof. So I'm going to work on this side. And right away, I see a tangent squared of x, which, according to our Pythagorean identity, has a secant squared of x in it, although I can never remember if it's a minus 1, if it's a plus 1, if it's a minus secant squared, if it's a plus secant. So I'm going to start with the one that I do know. You guys are probably better at memorizing. Some of you guys are better at memorizing these than me. And I know to get tangent, I need to divide by cosine. So I'm going to divide everything by cosine squared of x. So that's going to give me 1 plus tangent squared of x equals secant squared of x. Okay, I just want tangent squared of x by itself. So I'm going to take away that 1 from both sides. And then we're left with tangent squared of x being the same thing as secant squared of x minus 1. I kind of like that because that's the difference of squares. So that's going to be my first step, is to replace this numerator with that identity there. All right, so working the left side, we're going to say secant squared of x minus 1 over secant of x plus 1. And this is the difference of squares, like we said, so let's factor that out. We're going to get secant of x plus 1, secant of x minus 1 over secant of x plus 1. Okay, again, our goal is to get just cosines, so I want to try to get as few secants as possible. We can go ahead and get rid of this pair of secant of x plus 1. So we're just left with secant of x minus 1. All right, let's try to go ahead and convert these to cosines. So I've got secant of x, which is using our, what do we call it, reciprocal identity, is 1 over cosine of x. Okay, so that's not what we're looking for, but that's a piece of it. So if we go ahead and convert this minus 1 to cosines, if I want that to have a denominator cosine, I'm going to multiply the top and the bottom by cosine of x. So that's going to give us 1 over cosine of x minus cosine of x over cosine of x. All right, common denominator, combine them into 1, combine the tops, keep the denominator, and is that what we're looking for? Oh, yeah. Yep, that's what we're looking for. All right, so bring that down. And we're good. Got it. All right. How are we doing? What else? De nada. All right. What else we got? That's crazy. Data. Google's all about the data. All right. Okay, until somebody interrupts me, I'm going to pull another problem from the review packet. Or maybe, let's see. Maybe I'll throw in, this is a problem from the stations that we didn't get to in class. And we haven't done solving an equation yet. I don't believe. So we'll throw one of those in there, in here. You can access these stations problems at the bottom of the Unit 5 webpage. They've got solutions along there with them if you just need more problems in the next 15 hours or so. So this is number 3. This is station number 1. Number 3. And it says find all solutions in the interval between 0 and 2 pi. Without a calculator, and they give us cosine of 2x plus 5 cosine of x equals 2. All right, so we typically want 0 on the right side, so I'm going to subtract 2 from the first step. So cosine of 2x plus 5 cosine of x, take away 2, equals 0. The other thing I see is we've got this 2x here. These two will never be like terms if they don't have the same angle. Kind of like a root 3 plus a root 2. They're not like terms. We just can't combine them. It's like an x and a y. Okay, so until we get the same angle in there, we're not going to be able to factor. We're not going to be able to solve this. So let's go ahead and get rid of this double angle here. So our double angle identity for cosine, we've got those. That's one of the ones with 3 different options. They all start with, I believe it's cosine of x squared first, minus sine squared of x, if I'm right about that. I think so. And you can derive the other two, replacing each of these with a Pythagorean identity. The next one is 2 cosine squared of x minus 1. And I think this is the one that we want to go with because we really only want one type of a trig function here if we can help it. Okay, and with this one, we don't have to mess with any signs. We've just got cosine. So I'm going to replace all of this with 2 cosine squared of x minus 1. And then I'm going to bring down the rest of my equation. So plus 5 cosine of x equals 0. Okay, on the test, make sure that you take your time to make your work legible, both so that you can read it and so that I can read it. And so you don't make any silly mistakes, and I can go back through and give you partial credit. If the replace those cosines with a u or with a y or something, if that helps you to factor this to make it easier to factor. Okay, take the time to do that on the test tomorrow if needed. Okay, so split them off. Each factor could be equal to 0. And solve each one separately. So add 1, divide by 2. Subtract 3 from both sides. Okay, so if we start with this one, where on our unit circle does cosine equal 1/2? Cosine, that's our x. 1/2, that's going to be our 60 degrees here, which is pi over, good evening, which is pi over 3. So that's 1/2 root 3 over 2. And again, the direction said for angles between 0 and 2 pi. So we're looking for another angle with the x value of 1/2. So if we follow that down, then we're going to find this guy here, which is, let's see, 1 pi over 3, 2 pi, 3 pi, 4 pi, 5 pi over 3. Okay, make sure that if you need to, either on your index card, put a small copy of the unit circle, or at least the first quadrant maybe, or if you got that committed to memory when you get your test, or if you're not using an index card, make a little copy of it on the back of your test or on some scrap paper. I will provide scrap paper tomorrow, as much as you need for the test. So write big if you need to. Don't worry about trees tomorrow. All right, so those are two angles. So now looking at this guy, cosine of x equals -3. Not possible. The farthest it goes to the right is +1. The furthest it goes to the left is -1. You will never have cosines out to -3. So this is not going to give us any extra solutions. So we're looking at x values here. Going up to our original, we've just got cosines. Don't waste time plugging those back in and checking them, unless you want to check your work. If you have time, I would say after you've done the rest of the problems, maybe put a little star beside this if this were a test question. And when you've finished trying all the other problems, plug those angles back in. Make sure they work. You should get a true statement. Just remember, in a problem like this where you have double angle, to multiply that angle by 2 before you take the cosine of it. Doke. Yes. Checking the feed on my phone. I don't see anything. How are we doing? Number 3 from the review sheet. Yeah. Whoa. They're coming. I'm gonna get kicked out in just a few minutes, so I'm gonna see what I can answer until night school comes in. All right, so number 3, that was the next one on the review sheet. Catherine, I see you said it froze. I assume that this video will be watchable after the fact. I'll try to tweet out a link if I can get that to work. But I can't promise. I don't know how this works. Okay, number 3 from the review sheet. Again, this is not the practice test. This is that separate review sheet. All right, so we've got sine squared of x plus cosine of pi over 2 take away x, take away 1, plus cosine squared of x. All right, and the directions are to use identities and or factoring to simplify each expression. All right, first thing I see is this. That's not okay. That's not the same angle as these other two. So this is a good example of using our cofunction identity. The cosine of pi minus 2 minus x, pi over 2 minus x, is the same thing as what? Same thing as sine of x. So remember, for the cofunctions, they go with sine and cosine, tangent, cotangent, and then secant and cosecant. All right, so let's replace that first. Okay, so now we've got all of our angles the same. Let's see, what else? Okay, so next I see we have a sine squared plus cosine squared of x. If we group those together, that's our Pythagorean identity. Okay, on a problem like this, please write this step. If this were on your test tomorrow, so I can kind of see your thinking in the process. So this equals 1. You don't have to write what kind of identity it is, but show me in steps. Okay, so that's 1 plus sine of x, take away 1. So now we've got 1 minus 1. All right, combine those like terms. 1 minus 1 is 0. So 0 plus sine of x is just sine of x. And that's as far as we can go. All right, so I'm going to switch over to number 2 on the practice test, and then we'll go back to the review sheet. Hamid asked for this one, number 2 on practice test. All right, so number 2 says sine of x, cosine of x plus y, take away cosine of x, sine of x plus y. Okay, so we've got directions say simplify to a single term or value and to box our answers. So it looks like all of that looks like a single sine of the sum of two angles. So I wonder if we could write it. That's not how I did it though. So let's try this 2 ways. This is our sine of the sum of two angles identity. So it should equal the sine of our first angle. That's a minus x plus y. So then that would be x minus x. Oh, yeah, gotcha. So that would be, if we distribute that negative, wow, this is a way quicker way to do it than what's in the solutions. That's funny. So sine of x minus y is the same thing as the sine of, let's see, x minus x, that makes 0. So we've just got the sine of the opposite of y. We don't want to leave a negative angle in there. Sine is an odd function. So the sine of the opposite of an angle is the same thing as the opposite of the sine of that angle. And we're done. We can leave it like that. So much easier than the way it's done on the practice test. But if you did it on the practice test, you should get the same thing, to where you use your cosine of the sum of two angles identity and your sine of the sum of two angles identity, and then keep track of your terms, and you'll have several that kind of simmer down, cancel out using algebra, and you should get the same thing. Okay, those steps are laid out on the second sheet, the answer sheet to your practice test. Okay, but if you can recognize this as your sine of, I think in our notes it was like u plus or minus v. Let's write out that whole thing. Okay, so the sine of u plus or minus v, this is our identity, says take the sine of u, cosine of v, and then the sine was same sign. Okay, so plus minus, and then the cosine of the first angle, sine of the second angle. Okay, so this fits the same format as all of this. So in a sense, we're kind of working backwards in the identity. Usually we go from here to here, but this is a good example of going from here to here. Okay, and don't be scared of this x plus y. It still just represents the value of a single angle. Okay, even though it's a sum. All right, what else? I'm gonna go back to the review sheet. Oh, I'm sorry we did that. Oh. All right, let's look at number 4, the next one on the review sheet. Okay, so we're given, and I think we'll make this the last one. I usually get kicked out by now. All right. Directions say verify that each of the following is an identity. Verify the same thing, same directions as proof. Okay, so this is a proof. Okay, so looking at our two sides, the left side definitely looks more complicated. So let's start with the left side. Our goal is to get a single term. So somewhere along the lines, this sum is going to have to come together. So let's do cosine over sine. Do we want to? I don't know. How about let's look at simplifying this part first. Okay, cosecant is the same thing as 1 over sine. Right, times sine of theta. So that's just 1. Anything times its reciprocal is 1. Let's bring this down. So that's all just 1. Cosine over sine is the same thing as cotangent. So if we say that's cotangent squared of an angle plus 1. And then I know there's a Pythagorean identity that has both of these in it, cosecant and cotangent. So let's see if we can come up with that. So it's cosine squared of theta plus sine squared of theta. And this time we're going to divide by sines because we want our cotangent. We don't want our tangent. Okay, this gives us our cotangent. This gives us our plus 1. Hey, that looks good. And this gives us our cosecant squared of theta. So that's our identity. So we can just replace this, our last step, with cosecant squared of theta. Bring it down. That's what we're looking for. And we're good. Proved. Again, proofs are when it works for any angle theta. Okay, we're not trying to solve for a particular angle. Being called an identity implies that we could plug in any angle, and this statement is true. All right, let's. You're welcome, Mohammed. Let's see. I'm going to double check, make sure there's no more questions. Okay, well, I'm gonna call it and see if I can post this later. See how that works. Study. Make sure you have your note cards for tomorrow if you're choosing the note card over a retest, and get some sleep. See you all tomorrow.